Hello, I'm Swarnava Das, 16 BEC 0017 in the slot L53 plus L54, and this is my ECE lab task 3. The topic is filter circuits and the faculty in charge is Professor Dhanabal R. So what is a filter circuit? A filter is a device that modifies the amplitude or magnitude of an AC voltage as the frequency of the voltage changes. Here are the different types of filter circuits. It can be high pass filter, low pass filter or band pass filter. So what is a low pass filter? A low pass filter passes low frequencies and stops high frequencies as shown ideally in this figure. Here is the plot of the frequency response of a low pass filter, the amplitude versus frequency graph. You can see that the point where the graph is straight, where the amplitude is constant is known as pass band, and where it gradually decreases with increasing frequency it is known as transition band, and beyond that it is known as stop band. Here you can see the cutoff frequency of this low pass filter is 600 Hz. Here are some practical applications of low pass filters. Low pass filters can filter noise from a circuit. Noise is a high frequency signal which happens due to different kind of attenuation related problems. When passed through a low pass filter, most of the noise is removed. Low pass filters are also used in various audio applications and are sometimes known as high cut or treble cut filters. Here you can see a graph of a here you can see a diagram of a radio basically. Here there is a battery of 12 volts or a 12 volt source, and here's an inductor. Here's a capacitor in parallel with the radio, and the entire system is grounded to it. So high pass filter. What is a high pass filter? A high pass filter passes high frequencies and rejects low frequencies, as opposed to low pass filter, which is the opposite of this. A diagram of low pass, diagram of high pass filter is given right here, and here is and the graph of input versus output graphs of high pass low pass filter is also given. Here is the frequency response of a high pass filter, which is shown via a graph of output power versus increasing versus frequency. So band pass filter. What is a band pass filter? A band pass filter passes frequencies within a frequency band and blocks or attenuates frequencies outside the band. So basically it passes frequencies in a specific range of frequencies, and even if the frequency is less or greater than that range, then it blocks those frequencies. Here you can see the diagram of a typical band pass filter circuit, and there are also the graphs explaining that high pass filter and low pass filter together, basically combining them, the common region where the graph is constant can be shown as band pass filter. Yeah, here is the frequency response of a band pass filter, the amplitude versus frequency graph. Here the stop band is basically on both sides of the graph. Like in high pass filter there was only in the left side, and in the low pass filter it was only in the right side. But in a band pass filter, since it rejects frequencies at beyond a certain range and on both sides, so the pass band is in the middle, and on both sides there is the stop band. The center frequency here is 350 Hz. Application of band pass filters. Band pass filters are widely used in wireless transmitters and receivers. The main function of such a filter is to limit the bandwidth of the output signal to be allocated for transmission. Basically, band pass filters are used in all kinds of internet transmission nowadays. Without that, we cannot specify a bandwidth of receiving a signal in any kind of whether it be Wi-Fi or any other broadband connection. Everywhere there is band pass filter used these days. High pass and low pass filters are relatively less used. Here is the circuit diagram of the band pass filter. There is also something called band stop filter, which we are not discussing at this point. Band stop filter passes frequencies outside a frequency band and blocks or attenuates frequencies inside the band. So basically the opposite of band pass filter, but we are not discussing that right here. So here is the RC circuit, typical RC circuit that we are supposed to solve. The graphs are given right here. Here is the there's the here's the voltage across the inductor, resistor, and capacitor, and the frequencies for which the potential, the voltages are existing. You can see the graph. The graph shows all the three voltages for against frequency graph. There is the inductive voltage against frequency, resistive voltage against frequency, and also capacitive voltage against frequency. Here is the circuit diagram that we made in multisim, the one we solved to get the previous graph. Now this is the same for just an RL circuit. Here is the circuit diagram that we solved to get the similarly we solved to get the graphs and the values. Here is the graph. You can see again we have the inductive voltage, resistive voltage, and capacitive voltage. Now this is for an RLC circuit. You can see the diagram here that we made in multisim, and this is the graph. So yes, that's basically it. Thank you.